Question 15. If open bracket ax plus 2 close bracket times open bracket bx plus 7 close bracket equals 15x squared plus cx plus 14 for all values of x, and a plus b is 8, what are the two possible values for c? This has a touch of simultaneous equation with three unknowns, and there are two approaches to solving this question. You might start by taking this equation and either making a or b the subject of formula and insert it into the upper equation and see if you can find two possible values for c. Or you can do it this way: try to simplify this first. It looks too complex, then you might touch on the second equation. You have ax plus 2 in one bracket times bx plus 7 in second bracket equals 15x squared plus cx plus 14. It's supposed to be equation 1. Let's expand this. You have ax times bx. This ax will multiply this bx and this 7. Let's start with that first. In math, you have to try things that are mathematically allowed. So you have ax times bx. Ax times bx is the same thing as saying 2x times 3x. You have 2 times 3, that's 6. X times x, that's x squared. So you have ax times bx is a times b is ab, then x times x is x squared. So you have abx squared. Next you have ax times 7. You've multiplied it by this, you need to multiply it by plus 7. So you have ax times 7. That will give you 7ax with the positive plus 7ax. Next we go for the plus 2. Plus 2 times bx will be plus 2bx. Then plus 2 times plus 7 is plus 14 equals 15x squared plus cx plus 14. Looking at this, you might see it as strange, but when you're solving an algebraic question, like in this case, these two are like terms, and you might find it strange to see them as like terms. They both have x in this case. We see them as like terms because we're trying to match the coefficient of the like terms on the left with those on the right. But in some other situations, like simple algebra, you don't see them as like terms. But in this case, you have to see them as like terms, or you see that they have x in common and you bring out x. When you have 2x plus 3x, it's the same thing as saying x is common in both of them. You bring out x, then you'll be left with 2 plus 3. That's x. 2 plus 3 is 5. You can write it as 5 in brackets x. Still the same thing. So here, these two are like terms, or they both have x's. What you're trying to do here is a concept which could be referred to as the equivalent method. It's used in topics like partial fractions, equality of sorts, and factorization of quadratic equations. Same applies to this. Now, if this is equal to this, you will notice that the coefficient of x squared here is 15 and the coefficient of x squared here is ab. We can say ab equals 15. That is, we have created another equation. We have ab, or a times b, equals 15 as another equation. Let's note that first. Then this 14 is a constant and this 14 is a constant. They both match, but we need the value of c from this, and factorizing this, that's the like terms, would help us get the value of c, which will be in terms of a and b. So let's factorize it. We have abx squared plus, both these two have x in common. So you take out the x, let's put it on this side. If you take out x from this 7ax, this x goes off, you'll be left with 7a. So you have 7a, you can put it in bracket, plus. If you take out this x from this 2bx, you'll be left with 2b. So you have 2b close bracket. Then you have your x outside. if you multiply this x by both of them, you get back 7ax plus 2bx. We have plus 14, that's this 14 equals 15x squared plus cx plus 14. You know, what we have been trying to do is to see what we can get out of the first equation. And from the first equation, we've used the coefficient of x squared to get that AB equals 15. We can then use the coefficient of x to get C in relation to A and B using the equivalent method. If the coefficient of x here is 7a plus 2b, and this expression is equal to this, therefore 7a plus 2b equals C. Or you can bring them both out. You can have 7a plus 2b in bracket x equals cx. You know, both of them are equal to one another. This x cancels this x. You'll be left with 7a plus 2b equals c, which is the 7a plus 2b equals c. This is equation 1. This is equation 2. Then remember, from the question, we're given a plus b equals 8. And we have equation 3, which is a plus b equals 8. That's equation 3. With these equations, we can find the two possible values for C. A recap of what we did with the first equation, which is this, is to get two other equations from the original equation. Note, we can't just find C. We need to find A and B before we can find C. So with this first and this third equation, we'll find A and B, then substitute it into equation 2 to find C. So we'll take equation 1 and 2. Equation 1 says AB, that's A times B equals 15. And equation 3 says A plus B equals 8. Equation 1 and equation 3. This is a simultaneous equation that will lead to a quadratic equation. So in equation 3, we make A subject of formula, thereby creating equation 4. So you have A plus B equals 8. A equals 8 plus B crosses the equals sign, turns to minus B. Then we have equation 4, which is A equals 8 minus B. You can't substitute equation 4 into equation 3 because you created equation 4 out of equation 3. You can only substitute it into equation 1. So we have equation 1 as AB equals 15, substituting equation 4 into equation 1. And you know, in equation 4, A is the same thing as 8 minus B. So we change A to 8 minus B. So you have 8 minus B, that's your A, times B, that is this B multiplying the A, equals 15. This B affects both this 8 and this minus B. So B times 8 is 8B, then B or plus B times minus B. No, this B has a positive. Plus times minus is minus. B times B is B squared equals 15. I don't want my B squared negative, so I'm moving it to the right. I'm also moving this plus 8B to the right. So if we move it over the equals to sign to the right, you'll be having B squared or plus B squared, because minus B squared crosses the equals to sign and becomes plus B squared. We need to arrange it to look like a standard quadratic equation. Then the plus 8b crosses this equals to sign and becomes minus 8b. You know, this plus 15 is on the side we're moving these two other terms to. So you still have plus 15, and it's allowed. You can put your equals to 0 on this side, although the equal to sign should be on this side, but it's allowed in math. It's just to make sure the coefficient of b squared is positive to make solving this quadratic equation easy. Now this is a quadratic equation. And since the coefficient of b squared is 1, we just concentrate on this constant and minus 8, which is the coefficient of b. So we look for two numbers that will multiply to give us plus 15, yet when we add them it gives us minus 8. For you to multiply two numbers to give you positive 15, they are either both positive or both negative. And since you have a negative 8, they would have to be both negative. That's one complexity in this question that requires you to fully understand solving quadratic equations. Now we have 15 times 1 can be 15, but the best fit to this is 3 and 5. You have minus 3 minus 5. If you do minus 3 times minus 5, you get plus 15. Because negative times negative is positive. 3 times 5 is 15. Now if you take minus 3 and minus 5 and you add them together, they would give you minus 8. Because you have minus 3, then you have a positive and a negative sign together. You have to resolve them into one. It's same thing as saying positive times negative, it gives you negative. You have negative 5. Negative 3, negative 5, you're owing $3, you're still owing $5. In total, you'll be owing $8. So we've actually gotten the two values, which are minus 3 and minus 5. Let's write them on the side. Minus 3, minus 5. So you have b squared, then you take this minus 3 and add a b to it, minus 3b, then you have minus 5b. You also take this minus 5 and add a b to it. All you've done is to break down this minus 8b into minus 3b and minus 5b using 15, which is the constant, plus 15 equals 0. You group them in twos. We need to find what is common in b squared and minus 3b. In b squared and minus 3b, you have 1b in one of these two b's and a b in this minus 3b. So you take out b. The b will take one of the b's here, you'll be left with 1b minus b in 3b. The b will go off, leaving the 3 behind. You have minus 3 close bracket. Then in minus 5b plus 15, you have 5 common. You can find 5 in this, and you can also find 5 in 15. And in cases like this, you don't just take the 5 out, you take it with the negative. So like in this case, you can get b minus 3 in the second bracket. We take out minus 5. If you take out minus 5, negative divided negative is positive. 5 divided by 5, you'll be left with b. If you're sure of what you're taking out, you can just repeat b minus 3 without stressing yourself. Now you've taken out minus 5. You have plus 15 divided by minus 5, or minus 5 in plus 15. You have plus 15 over minus 5. Positive divided by negative is negative. Then 5 in 15, or 15 divided by 5, you have 3. You close your bracket equals 0. You know you're right when this value is the same as this. Next, you pick one of them. You have open bracket b minus 3 close bracket. Then you join this external b and this minus 5 in another bracket. You have b minus 5 in second bracket equals 0. This is where you apply what we regard as the equivalent method earlier. You have b minus 3 equals 0, or b minus 5 equals 0. b equals minus 3 crosses the equals sign, it turns to plus 3. But standard in math, you say add 3 to both sides. The effect is still same as saying minus 3 crosses the equals sign and turns to plus 3. Or we have b equals minus 5 crosses the equals sign and turns to plus 5. b is either 3 or 5. So if b is either 3 or 5, we can therefore get the values of a, which will then lead us to get the values for c. We know our b is either 3 or 5. So we'll look for a when b is 3 and we'll look for a when b is 5. You can either take equation 1, equation 3, or equation 4. You can use equation 4. Let's use equation 4. A equals 8 minus b. That's equation 4. Let's take when b equals 3 first. What's a? A equals 8 minus 3. You know, we've changed the value of b to 3. You have a equals 8 minus 3, that's 5. So when b is 3, a is 5. So a is 5 when b is 3. You know, we have two values for b. The second value for b is 5. What's a when b is 5? We still write equation 4. A equals 8 minus b. We take b equals 5. You have a equals 8 minus 5. You know, b is 5. So you have a equals 8 minus 5. 8 minus 5 is 3. So a is 3 when b is 5. So you say a equals 3 when b equals 5. Remember, we've been asked to find the two values for c, and we have worked with equation 1 and equation 3, and we still have equation 2 that has c in it. Equation 2 that has c in it is 7a plus 2b equals c. We take these two values first to find c. That's a is 5 and b is 3. That you see, when a is 5 and b is 3, what is c? So we have 7a. 7a is 7 times 5 because a is 5. So you change a to its numeric value, which is 5, plus 2. then B is 3 times 3 equals C. You have to be careful here. This is both math. You multiply them separately before you add them. If you add before multiplying, you get a wrong answer. You have 7 times 5, that's 35, plus 2 times 3, that's 6, equals C. 35 plus 6 will give you 41. That's one of the C's is 41. This might be enough for you to get your answer. Going to our options, the only option that has 41 is D. So D is your answer. But to fulfill all righteousness, let's find the second value for C. We've now cleared that one of the values for C is 41. Now using when A is 3 and B is 5, we'll find the second value for C. Let's separate it with a line. You have equation 2, 7A plus 2B equals C. The only equation that has C in it. When your A is 3 in this case and your B is 5, what is C? So you have 7 times 3, your A is 3, plus 2, your B is 5, times 5 equals C. 7 times 3 is 21, plus 2 times 5 is 10 equals C. 21 plus 10 will give you 31. C is 31. The two values for C are 31 and 41. Going to our options, like said earlier, from getting one of the values for C, our answer is D. That's 31 and 41. A quick summary of what was done is that we used this first equation, which was written here, to derive two other equations, which we named equation 1 and equation 2. We used equation 1 and equation 3 to find the two values for A and the two values for B, then substitute each set of values into equation 2 to find the two values for C. This is one of those questions you save for later if you don't get it once. If you don't get what you're meant to do once, you can save them for later and come back to them. Because the exam is not about you completing a question before you go to the next one. It's time-based, and like explained, if you get one of the results, you can go to your options and see if you have it in just only one of the options. Then you can tick it and not bother about finding the second value. I hope you understand.